My name is Sarah Maebius,
And I'm Alex Flowers.
and we worked over the summer conducting research using forestry data from the Forest Inventory and Analysis Program, or FIA for short. We performed a simulation study to determine how the FIA should estimate the variance of a population estimate, such as the mean number of trees, under a systematic sample. Having reliable variance estimates is necessary for constructing confidence intervals and performing hypothesis testing. Currently, the FIA follows a quasi-systematic sampling design, but for the purposes of our project, we focus solely on a systematic sampling design. A brief review of a systematic sample is that you randomly select the starting location and space the rest of the observations in the sample at a set distance apart to form a sample resembling a grid, such as the one on the right. Note that this sampling method only works with a population that doesn't showcase any patterns to ensure that the grid design is not systematically picking the same values. This method is simpler and cheaper than simple random sampling, with the added benefit that it avoids any clumping that we typically see in randomly selected samples, which could lead to over or under representation. The idea behind our investigation is that by providing an even coverage of the landscape, a systematic sample leads to more efficient estimation and reduced variance. A well-known formula exists for estimating the variance of a mean estimate under a simple random sample. However, estimating the variance of an estimate under a systematic sample presents complications in the joint probability of inclusion part of the variance formula. The general issue is that a systematic sample only requires one random draw to select the entire sample. As a result, it is a common practice to just treat the systematic sample as a simple random one and estimate using the variance formula for SRS. Our project answers the question of whether this assumption is appropriate for estimating the variance.
To answer this question of whether the SRS assuming equation is a problem with FIA data, we decided to perform a simulation study using real-world vegetation data. For population data, we used a satellite map of a vegetation index, NDVI, in Daggett County, Utah. We conducted our simulation by taking many samples from this map, and for each, calculating the mean NDVI and an estimate of the variance of the mean NDVI. This gives us a distribution of mean estimates, which you can see on the left, as well as a distribution of variance estimates, which is on the right. This is something we could do with any population estimate and not just the mean. In any case, we then treat the actual variance of the population estimates as truth and compare that against the average variance estimate to get a sense of how biased our variance estimation method may be. We were able to obtain some initial results using our simulation. This graph shows the relative bias of three versions of the simulation using three different sample sizes. The green and blue lines both show relative bias when using the SRS assuming equation for two slightly different mean NDVI population estimators. The orange vertical line represents the approximate FIA sampling density. As you can see, at the sampling density that the FIA uses, there appears to be a roughly 20% bias with the SRS assuming variance estimates. Notably, however, the red line shows the results of an alternative variance estimator taken from the literature that tries to account for spatial autocorrelation in the landscape and which appears to decrease the bias. The reason that these results are only preliminary is because the sampling method we were able to implement during the summer does not reflect as much randomness as actually occurs in the quasi-systematic design used by the FIA. In any case, we can make a few conclusions. Our results indicate that there is cause for concern that using the SRS assuming variance estimator is leading to the FIA overestimating variance. If this is the case, the FIA could be using over-conservative estimates for its land management recommendations and decisions, which is less than ideal in a time of increasing concern for the health and safety of our nation's forests due to climate change. If you're interested in reading more or learning about future steps we'd like to take, feel free to check out our report. We'll post a link in the comments.
That concludes our presentation. A huge thank you to all of the organizers of the Undergraduate Statistics Research Conference for the opportunity to present and share our summer's work. Thanks for watching.